Hey y'all, welcome to chapter 9. Wow, the end of the year is so close. You can smell it, you can taste it. It's almost there. We got a little bit more hard work to do between now and that summer break, so let's get to it. Section 9.1, multiplying and dividing rational expressions. Let's get a little review going on. So if you wanted to simplify a fraction, oftentimes what we do is we say we divide, find a greatest common factor that can divide 56 and 35. But if you wanted to, you could also write it out like this. Like 7 times 8, 56 is 7 times 8, and 35 is 7 times 5. And we know we can cancel these things because there's multiplication here. 7 and 7, they cancel. And so it's just 8 over 5. Here, we could also, if you wanted to go the long route, you could kind of like write out everything. 35 is just 7 times 5. X squared is just x times x. Y cubed is y times y squared. 14 is 7 times 2 times x times y. And you can see that if there's multiplication up here, you cancel. Cancel the 7th, cancel an x, cancel a y. And what you're left with is 5xy squared over 2. That's just what's the only thing that's left in the denominator, or only thing left in the numerator. This is another way of thinking about simplifying these fractions. We have to remember how to factor. So remember, there's a greatest common factor of 5, 15, and 140 is 5. So you divide all three terms by 5, and you get x squared minus 3x minus 28. And then, splitting the middle, we get x minus 7 and x plus 4. And that's how we factor. Let's practice some more factoring. We have to remember that here, if we wanted to split the middle, there's no greatest common factor, so you can't factor it out like it's 5. And if you wanted to, you have to make sure you have to multiply 4 times negative 1, which is negative 4. And so you need two numbers that multiply up to negative 4 and add up to positive 3. Well, they happen to be 4 and negative 1. And so that's why you split the middle this way. Then you can factor out the 4x here and factor out just a negative 1 here. And you're left with, surprise, surprise, if you did it right, you get x plus 1 twice. So you pull the numbers out here, 4x minus 1, and the leftovers are x plus 1 right here. Let's do that again here. So I think there's a greatest common factor of 3x, because 3 goes into 12 and 3 goes into 3, and then there's only one x between them both, and then the leftovers are 4x minus y to the fourth. Let's remember how to divide fractions. Something like 2/5 divided by 7/9, it's the same thing as multiplying by the reciprocal. So 2/5 times the reciprocal now is 9 over 7, which becomes 18 over 35. We're going to need all those skills. And we're also going to have to avoid the big canceling mistake. Don't you dare commit the canceling mistake. You've got to avoid it. So let me show you what this looks like. What you can do is you can cancel factors which are separated by multiplication. Cancel those factors. You see, these are separated by multiplication, separated by multiplication. That's all well and good. What you can't do, you can't cancel terms which are separated by addition. Let me show you what it looks like. So you can see here, the big canceling mistake is in red, and what you really should do is in green. So yeah, what you really should do is add these two together, and you get 12 and 6, and then you can cancel out the 6 and the 6 because it's separated by multiplication, which becomes an answer of 2. Type this into any calculator and hit enter, and you'll get an answer of 2. But people who commit the big canceling mistake might look at this addition and just ignore it and say, I'm allowed to cancel these 5s. Look, I see a 5 and a 5, and I will cancel them, and I will get 7 over 1, and the answer is 7. No. Avoid the big canceling mistake. Check this out. What you should do is you should add to get 4 over 16, and then, of course, the greatest common factor between these two is 4, which you can separate with multiplication. Cross out the 4, cross out the 4, becomes 1 over 4, which is the leftovers over here. Now, if there's some people who might look at this addition and they say, ooh, wait, I see 3s. This addition means I can cancel. La-di-da. I will cancel this 3 and this 3, and I will commit the big canceling mistake. No, don't. The answer is not 1 over 13. It's 1 over 4. That's just the value that it is. When you do PEMDAS right here. Don't cancel with addition. Only cancel with multiplication. Let's look at it here. 5 plus 2 is 7. 5 plus 9 is 14. You can cancel these 7s because it's separated by multiplication. What you can't do is you can't cancel with addition. So you see the addition here, 5, 5, no. Can't cancel terms. You can only cancel factors, which are separated by multiplication. That even extends into variables. People might see this x, and they might say, ooh, I can cancel. I see an x here and an x here, and they go 1 over 2, 1 over 2, and they get maybe, I don't know, another 1 over 2. They get 2/4, which simplifies down to 1 over 2, and that would be wrong. But what you can do is you can factor out a greatest common factor of x plus 1. You can see here, this, if you factor out in the denominator, if you factor out the 2, then it becomes 2 times x plus 1. 1 times x plus 1. And there is multiplication separating these factors here. 1 times this, 2 times this. And they cancel out and you get 1 over 2, which is perfectly legal. Even though you see there's addition right here. What you're really doing is you're canceling factors which are separated by multiplication. Let's see. So in this section, it's going to be incredibly important to make sure that before you try and do any canceling, you do factoring first. Separate things out into factors. It's even true here. You can separate these out into factors, you separate these out into factors, separate these out into factors. So as a first step, let's factor the numerator. Aha! I see a greatest common factor of 3, so I can factor that out and get 3 times x minus 4. 3 times 4. You can cancel out the 3's and you're left with x minus 4 over 4. What you can't do is you can't cancel out these 12's because you just see 2 12's right here and there's subtraction. No, that would be wrong. And you're producing something over here that is not the same as the original, not equivalent to it. Here, there's a whole lot of factoring we can do. We can factor out the in the denominator. I would probably see this problem and look at the denominator and say, ooh, I can factor out the denominator. I get a greatest common factor of 3x. Don't forget the variable, don't forget the number. You have to factor out them both. 3x is the greatest common factor, and we can factor out a 3x from the numerator as well. So if I want to cancel a 3x from the numerator and denominator, then that's great because they're separated by multiplication. And I get 9 over x minus 3, which is equivalent to this for the most part. The only time it wouldn't be equivalent if you try to say that if x were equal to 0. So if x equals 0, you get a number here, but you don't get a number up here. But aside from that, it is completely equivalent. Here you might see the 36x and the 9x, and because there's subtraction here, and you ignore this subtraction, then you might do some sort of canceling and get a 4, and that's just wrong. So please avoid the big canceling mistake. The big idea is you can cancel factors that are separated by multiplication. Don't cancel the terms which are separated by addition. Let's see what this looks like. Simplify. You may leave the answer in factored form. Thank you. And factor first if necessary. Of course, definitely factor first. So let's see what we got. We got a 49 and a 7. Ooh, that means I can split this 49 into 7 times 7, and I'll be able to cancel the 7 in the numerator and 7 in the denominator. I see a w minus 4 and a w minus 4, and these are separated by multiplication, so I can cancel them. W minus 4 and w minus 4 cancels. And what I'm left with is 7 times 3x plus 2 over 3w plus 5. Now, a purist would probably try and get rid of all the parentheses. That's often what simplify means. It means just get rid of all the parentheses. But you remember here in the instructions, it says you may leave the answer in factored form, and there it is. It's still in factored form, and it's going to save us. It maybe distributing here wouldn't be that big a deal, but in other problems, it's a much bigger deal and a lot of work that we're not really asking you to simplify or testing you on simplifying at this point. We just want to test you on. We want you to practice the skill of canceling and factoring. So here I see w's in the numerator and the denominator. I see multiples of 6 in the numerator and denominator. I see w minus 1's in the numerator and denominator, several of them. Okay, and I see only a 2w plus 1 in the numerator. So what I can do is, let's start with the 60 and the 18. I can factor out a 6 from both of these. Dividing them both by 6, you get 10 over 3. Then I see 3 w's in the numerator and 4 w's in the denominator. So three of them will cancel out, leaving only 1 in the denominator. I see when I'm looking at w minus 1's, there are 2 of them in the numerator and 5 of them in the denominator. So if I cancel out 2 of them, I'm left with 3 in the denominator. 5 minus 2 is 3. And there's more down here, so the leftovers go down here. And the 2w plus 1 gets carried along for the ride. Here's a tricky one. Negative 6 plus v and v minus 6. The savvy math student will see that all you really got to do um, is rearrange the numerator. You get v, and like if you put just v first, it would be v plus -6, which is the same thing as v minus 6. And if you cancel these out, you get 1. Assuming that v isn't equal to 6, that would make the denominator equal to 0. Okay, here, very similarly, if we're going to rearrange things, you could actually, what we want to do is we want to create some sort of simplifying that would go on. So you could actually factor out a -1 from the denominator. And if you do that, the numerator remains untouched, but the denominator is -1 times 8v minus 3. It's a quick and dirty way of rearranging something with subtraction. So you can see the 3 came first, and now the 3 is coming last. But if you're unsure of what this looks like or why it's allowable, if you were to redistribute this back in and get rid of the parentheses, you get -8v plus 3, which is equivalent to the original. But it's great to factor out a -1 because then you can cancel 8v minus 3 from the numerator and the denominator. You're left with 1 over -1 or just -1. Let's do some more factoring. So you can see here x squared plus 2x plus 1, 4x squared plus 3x plus 1. Well, if you were going to commit the big canceling mistake, you might just immediately cancel the 1's out and the x's and the x. You might just go to town canceling out immediately, and you can't because it's all separated by addition and subtraction. What you really have to do is factor, so that you have things that you can cancel with because they're separated by multiplication. These factors here. If you factor the numerator, you get this. Factor the denominator, you get this, and you see an x plus 1 in both the numerator and denominator. So you can cancel one of them each, leaving just x plus 1 over 4x minus 1. That's the answer. Here, I don't see any. There's just subtraction here, so I can't cancel until I introduce multiplication here. You might cancel the 16 and the 16 and the w's and the y's immediately, but you'd be committing the big canceling mistake if you didn't first introduce multiplication. So let's factor out the greatest common factor, which is 4y squared. And you have the leftovers here. And you can also factor out 4y squared from the denominator as well. So when you do that, the leftovers are here. And then 4y squared cancels in both the numerator and the denominator, and you're left with this. Moving on, let's see. Here, we've got two fractions that are being multiplied by each other. Well, if you're going to multiply them by each other, actually, I didn't show you an example of this with just numbers, but you can also cross-cancel with just regular numbers. Like if you had 4 over 8 times 6 over 3 or something like that, you can cross-cancel in the same way that you cross-cancel here. Don't confuse it with if there were an equal sign here. You can actually, we're basically just extending. Let me take the short version. The short version is we're basically just going to extend this bar so that's one fraction. Because when you multiply fractions, you're just going to multiply across anyway. So you might as well cross-cancel first. I see an x plus 8 because we factored the numerator here and you factored this numerator here. We see that actually you can cancel out an x plus 8 from the top and the bottom. And then, so there's just a 1 right here and a 2 right here. 2 times 4 is 8, and we're not required to continue distributing because the instructions said we can leave it in factored form if we want. Let's see, and if we're dividing, then you can see here it's 5x plus 10. That can get factored here. 6x minus 42, that can get factored here. These can't get factored, but you can change this from division to multiplication by taking the reciprocal. Notice the x minus 7 went from the bottom down up to the top. And so now that we've written it this way, it's a lot easier to see that you can cross-cancel an x plus 2 here and here, and an x minus 7 here and here, and it's 5 over 6. So it's interesting to note that no matter what value you put in to this here, just so long as you don't actually get a 0 in any denominator anywhere, then no matter what value of x, it's going to turn out to be 5 over 6 when you compute the numerical value. So like x can't be 7 and x can't be -2. But as long as they're not 7 and -2, then you're good. And you can, and like if you put in, I don't know, choose 0 or choose a million for a value for x, and you compute all this out, you'll just get 5 over 6 regardless of the x value. Fractions within fractions. Holy smokes. So this is a fraction within a fraction. And so you can see you got the top there's one, two, there's like A, B, C, D different things. And so I guess the easiest way to deal with fractions within fractions is to turn them into dividing fractions. So you've got A, B, C, D, C, D right here. So basically, like, this middle fraction bar turns into a division. It's this giant fraction divided by this giant fraction right here. And so once we do that, we no longer have fractions within fractions. And maybe the first thing we should do is factor. I see a greatest common factor of 5 you can pull out here. And if we want to get rid of the division, then you can put the numerator, you can flip the second fraction only. And you can see 2x plus 14 can get factored into 2 times x plus 7. So you can cancel a 3, the 21 and the 3 have the greatest common factor of 3. You can cancel the x plus 7s. You can cancel 2 of the x's. There's 2 down here and there's 3 up here. So the leftovers turn out to be 35, because this is 5 times this 7. And there's an x here. And I'll leave it to you to figure out what exactly is the leftover for the denominator. Also, I just wanted to drop at this point, I just wanted to name that I've got 3 kids, and my oldest kid is named Elliot, and his middle name, here's what I'm really dropping. You might know that my son's name is Elliot, but his middle name is David. He's named after a pastor that we had at the time who was very influential in our lives. Pastor Dave, this one goes out to you. Take care, y'all. Thanks for sticking with me, and I'll see you in class.